Okay, recording. Fantastic. We're going to look at exercise 4C. I want to do 4C out of exercise 4C. Um, yeah. And I also want to do 4E. Okay. So, 4C, well, let's read the whole thing. Use the fundamental theorem of calculus to find the area between the x-axis and. Okay, we'll explain what that means in a minute. I just want to write out the question. I think I might use f of x notation instead. So the function, right, we're doing exercise 4C, question 4C, no coincidence at all. So the question was also 4C. They've given me this function and it equaled square root x. That's right. So the fundamental theorem of calculus is that if I wanted to find the area under the curve between 1 and 2, I could take the integral and what that's equivalent to is the antiderivative, all right, at x equals 2 minus the antiderivative at x equals 1, right? Excuse me. So what is the antiderivative? The antiderivative, we can find it by taking this, and by the way, it's easier to do it like that. We say x to the power of a half instead of square root x. You find the antiderivative by add 1, that's x to the 3 on 2, and then divide by whatever your power is, divide by 3 on 2. And then to tidy that up, we want it times by 2, so we just, have a simpler fraction here. So we'd end up with 2x to the 3 on 2 all on 3. Now, let me think. It might be easier for you just to get there in one step. What I mean is, given that your power went up to 3 on 2, and you know you have to divide, by 3 on 2, you know that that's the same thing as multiplying by 2 on 3, right? You just, when you're dividing by fractions, you can turn it into a multiplication as long as you take the reciprocal. And then you could just whack in the 2 on 3 right from the get-go. So you might prefer just to do that. We could go straight to the antiderivative that way. We could say it was 2/3 x to the power of 3 on 2. Okay? Now to evaluate this area, I've got to use my antiderivative where x equals 2. So I need a 2 here. 2/3. Now to be times 2 to the power of 3 on 2. I think I might do this. 2 to the power of 1. 2 to the power of a half. There's my 3 on 2 if I add the powers. And I have to subtract away 2/3. Now the x equals 1 here. 1 to the 3 on 2. Well, 1 to any power is just 1, so that's easy. I'll end up with, I can see denominators of 3 everywhere. We could whack them in now. We're going to get 2 times 2 is 4 times root 2. So we've got 4 root 2. 4 root 2 on 3 minus, this is just 1. 1 times 2 minus 2. Okay? And that's the area that we're looking for. Okay? Found from the antiderivative. Now I want to talk about this graphically. So what I've done is gone to Desmos. Where are we? Desmos here. And I've drawn, get rid of that one. Excuse me, recovering from a cold here. I've drawn the f of x function, the y equals square root x, and I've put in the area that we're looking for. They said the area's got to go from 1 to 2, right? So it's this green area. Okay, so the fundamental theorem of calculus is saying this area, right, can be found if you know the antiderivative of this function. And the antiderivative of that function is this one, right? Looks quite different. And you need to find the difference between where x is 2, which is up there. All right, now when x is 2, it says the y value is 1.886. So that should be my 4 root 2 on 3. And then you have to minus away where x equaled 1. Where is it? There. And that would be my 2 on 3, 2/3. And if I did that one, where x equals 2, 1.886 minus where x equals 1, I get this area. Okay? So we could check it with technology. Right? The book says you can check with technology, and that's what I did here. I might actually retype this. So to show you how to do it. What I've done is gone to functions. It comes up down the bottom of Desmos. You've got to click on this little keyboard. You go functions, you go integral. We're evaluating from x equals 1 up to x equals 2. We type in our function. It's square root of x. Make sure that you write with respect to x, and bang, there's the answer. Right, and I'm presuming that 1.21895 is the same as, let's have a look, I'll just clear, I had, what did I have? 4 square root 2 minus 2 all on 3, and that should equal the same value. Yep, good. Okay. All right. So we'll do one more. This last one here looks a bit harder to integrate, right? So we've got y equals 1 on the square root of x. But if you turn that into an indices using fractional powers, it's going to be fine, right? So I'll write it with this notation. Little f of x is 1 on square root of x, but that's the same as x to the minus 1/2, right? So I'm writing, that's the function we start with, just f of x. The antiderivative, I'm using a capital F, okay? We find it by adding 1 to the power. And then we need to then divide that by the new power. We need to divide by half, but dividing by half, well, that's the same thing as timesing by 2, so let's just whack a 2 in there, and we're done. Okay. So, what question was this? 4e. Just write that in for your reference. So, now in 4e, we were evaluating from x is 1 up to x is 4. Okay. So we'd write the integral from 1 to 4 of the function with respect to x equals 2x to the half, and I'm going to evaluate that from 1 up to 4. So what we're doing is we're going to look at the antiderivative where x equals 4 and subtract away the antiderivative where x equals 1. Okay, we need to make our x's 4 to begin with. We've got 2 times square root 4, right? That's antiderivative where x is 4 minus, now our x is going to be 1, 2 times square root 1, and that's just 1. So we've got square root 4, that's going to be 2 times 2, right? So you've got 4 minus 1 times 2, sorry, that should be a 2, because we've got 2 times 1 is 2, and that equals 2, and we're done, all right? Okay, I'll pause it there, and then we'll continue with some more questions in the next video.